Yeah, it's a toothless job. It's like, okay, yeah, it's like handing out parking tickets or something. It's like...
Hi, and welcome to our Specific Group podcast. We're here in London today with Joe Reis to talk about data engineering, everything data, and experiences and learnings from his new book, Fundamentals of Data Engineering. Go, camera see it. It's been a book that is very popular among practitioners, among customers, among our people, and let's talk about why and how data engineering became so important.
Sure. It's good to see you.
Good to see you in London.
Yeah, likewise.
How was your trip?
It's been great. Yeah, kind of a whirlwind, coming off the heels of recently being in Australia, and then New York City, speaking at a data-driven MIC, and then here, London's cool. First time here too, surprisingly enough. But had a fun time at the meetup last night. So we met for a bit. So yeah.
Yeah, data meetup was great.
Mm-hmm.
It seems the field is really, I'd say it's booming right now. What do you think makes the discipline of data engineering so unique and distinct from, let's say, backend development, classical SQL development? Like, how's the business value measured in data and this becoming so important?
Let's start with the first part. How is it different than maybe some other engineering fields? I feel like data is, it's unique in the sense where maybe you're dealing with larger volumes of data and the end use case is doing something with data, right? So it's a bit different than an application where you're using data maybe to perform a transaction or some sort of an automation or an event. Those types of use cases tend to be a lot more discrete,
Right.
Whereas data tends to be more applicable maybe to machine learning or aggregate statistics or analysis, something like that. And the value is interesting. Value is that's a tricky word to, I think, identify. It depends on the context. I think with respect to downstream customers, really, and I define value as something that is something that a customer wants at the end of the day, right? So,
Right.
Maybe classically, a data scientist, for example, is you always hear the cliche that they spend 80-90% of their time, munging data, preparing it, cleaning. I mean, that should be the job of a data engineer, which then frees up the data scientist to better utilize their skills, which is probably algorithms and modeling and so forth. So I'd say maybe that's one of the value adds. It's shortening that time, to the data scientist or analyst to be able to do their job.
To actually bring something to life that is more than simple if then else or rule-based stuff.
Exactly. Yeah, but again, value is very subjective. I think it ultimately depends on what the whole data team has been hired to do for the business, and so that's
right. So they can focus more on the. It's been kind of the theme for years, right? They can focus more on their core activities, but then they weren't really certain what those are after they got lost in data wrangling for years.
Yeah, exactly.
You talk a lot about the fundamentals in the book, right? So those are things that we figured are, kind of the theory behind this whole vendor type. Like what's behind it that makes it like a blend of, classical software engineering and other newer things. Which of the fundamentals from the book do you believe are the most critical, the least likely to change and should be, let's say, mastered first if someone is a software engineer or not and wants to break into this field?
I'll start with the last part of your question. If you're a software engineer, I would say you already know how, one of the, so we talk in terms of the data engineering lifecycle. So source systems that software engineers might be responsible for, storing the data, along the way ingesting it, transforming it, and then serving it, to downstream users. I would say that, so the software engineer is going to understand the source systems, hopefully. Maybe they don't, I have no idea. But that's a good place to start. I think maybe understanding how data is ingested and how it's going to be used downstream. In fact, the one thing I would say is the software engineer should maybe skip all the way to the end and understand how maybe what a data scientist or analyst wants. Because then you build the empathy to kind of understand, okay, so end to end, what am I trying to provide? Then you can kind of work backwards from there. What I see all too often is people kind of focus on the next step, from source systems to ingestion. They only get that piece of the puzzle corrected, understood, but it's still a long ways to go. So I'd say maybe understand what what the end use case is and understand how people use data. As far as the most important parts of the life cycle. Well, there's also undercurrents that we talk about. And I think the most important one's probably security, because if you get that wrong, it doesn't really matter, how fancy, your pipelines are, your data model, like you screwed up pretty bad.
Whether in the basement or in the cloud, security has to be a part. It's like security, information security, data privacy. All of those things are clearly one of the fundamentals. But you mentioned also, that the data engineer should understand the upstream systems and like what the data will look like and why it looks like this, but also how are then end users going to use it, which is more kind of into the how rather than what a classical software engineer would look for just functionality, right? This is kind of the new thing that may be misunderstood, right, by many. I mean, why do you think the book resonates so much within the data space? I mean, you obviously been getting great feedback and traveling around the world talking about it. What was the kind of when synthesizing all of that information in this huge field of data? What was the mislink that you think everyone found useful?
I mean, up to the point of this book, before, I think the only ways you could really learn data engineering was sort of either on the job. You could read Martin Kleppman's book, Designing Data-Intensive Applications, which is awesome. Great book, but I think the feedback in that book is it's awesome and timeless, but it's also like it throws you into the deep end pretty quick. There wasn't really a kind of an on-ramp to that book. It's just sort of, get into it and good luck. And then there's some, I think there's some good books on, maybe data engineering as it pertains to platforms or technologies, like data engineering in AWS or, Python or whatever. But I think if you take a step back, I mean, one of the reasons we wrote the book was that, okay, so what's going to be timeless and what could serve as a foundational book that shows the context and sort of just the underlying thinking of data engineering, not just how you apply it to tools. Because I think up to this point, nobody had really defined data engineering either as a field or a practice.
Right.
And so I think it's resonating precisely because it's so simple. Frankly, it's a very approachable book. Current data engineers are going to get a lot of value out of it. One of my old school data engineering friends, he'd been one of the first users of Hadoop in the world, and so he's kind of a data engineer. But he even said it was like, I've learned a lot, and it's crazy how much you have to know these days. And so, but data analysts, project managers, product managers, software engineers, kind of everyone's finding utility from it, which I think is pretty cool. Like it's approachable.
It's approachable, right? Right. So we had the case where intuitively right, if someone's AWS engineer, well, and if they want to work on an Azure project, you could still extract the fundamentals, but it's more intuition rather than okay, here's what they are, right?
Yeah, happens.
Where do you generally see the complexity or simplicity in the industry going? Like, if you specialize in data engineering right now, you just said you have to know a lot of things, but also things are getting easier. Things that used to be huge. I remember in the Hadoop space, you had to have really kung fu masters to run the system.
Yeah.
And now it seems like similar use cases could be done with.
Well, let me ask you this. I mean, back when in Hadoop times, I mean, how much time did you spend doing? How much time managing that Hadoop cluster versus any other type of work, like anything higher level data management, anything, right?
It was engineers engineering type of work, mm-hmm. But then I think it kind of was still successful despite the huge effort in engineering, because ultimately the first generation big data actually solved the pressing problems of the day. Mm-hmm. But these use cases are no longer relevant or don't have the same economics. So right now it's much more difficult to justify why would you be rendering Hadoop?
Yeah, it's gonna be crazy. Yeah, and I was talking to my friend Jordan Tagani too, and he had a good point with the he's guy who co-created BigQuery, and he had a good point when he's project manager or product manager over BigQuery. He noticed that most of the data sizes were actually really small.
Right.
So he called it easy query actually because it's really easy to use, but it wasn't really like a big data engine per se. And so, and I think that's sort of the point, right? Where a lot of this, there's a lot of abstraction now over, what used to be hard problems of just lots of data. to me, kind of the big data is sort of a misnomer. It doesn't really apply anymore. It's just data, whether it's big or small. It sort of doesn't really matter at all. Like, I mean, I'm sure you recall the kind of the contest people would have about the size of data they were handling at the time, and now it's like it's laughable because some companies will be using megabytes of data alongside petabytes.
It was back then. It was almost like an exercise. Let's just find whatever data we can find and put it into a data lake, and let's figure out later where we're doing it. And now it's more like, okay, what's the real value? Let's look at that first. And I come from banking, and in banking we just don't have big data. By any stretch of the imagination, the data is not big.
But you have useful data.
And there's things you can do to add value to the customer, to the business, and things that are just pure engineering exercise for the fun of it. Now, there's people talk in the data warehousing space. Everyone wants to move to more kind of reduce the time to insight, reduce the latency of the data and reports and whatnot. What's your prediction on the live data stack? Like this is obviously the barriers and costs are coming down, but how quickly and how do you see this being more accessible? To have to move away from this T-1 data warehousing that is so predominant into a more like...
Yeah, so I mean, for the audience, the live data stack is something we referenced in the last chapter of the book of sort of a what's next, what's coming in data engineering. And that was a fun chapter, right? Because you'd be totally wrong and people still like, wow, that's amazing. But I think the live data stack, right? So the notion of this is the feedback loop between applications and data sources and results are going to be shrinking a lot. Whether that means the data warehouse is still there, it's going to be there, but probably in a different way. I think you're talking the rise. What I think is coming up is really a rise of commodity stream and stream processing and transformations. Alongside the ability to integrate that much more quickly into machine learning, for example. And so the essence of and for reporting, it's basically what and when type questions. That the responses to those really should be automated, especially when you're getting live events. Like when you're looking at a chart of like what happened, like what action are you going to take from that? And if you in real time, it's probably like, okay, so if I can take an action, then why don't I just automate that action?
Right.
Why do I need to keep looking at a report if I'm just going to so as the actions occur, figure out responses to those and maybe tell me what happened after. And so I think that's and again, that what you're going to see is this notion of data product, but what I consider to be a data product is like end to end.
Right.
Data feeds the application as well, and it always has, but I just feel like that feedback loop is going to get a lot tighter and tighter and tighter. The modern data stack, I mean, it served its purpose. What I really think served the purpose is it got people out of having to spend millions of dollars on contracts with legacy data warehouse vendors, on-prem, and it moved things to the cloud so you can kind of pay as you go. That comes with its own challenges, obviously, but what it meant is you can do things in the cloud with greater abstraction and freedom of separate storage and compute. But I can't stand here and think that this is like the pinnacle of where we are as a field. That would be odd. But and so we really just took data warehousing and put it in the cloud with some better tooling at the end of the day. Right. But I feel like we're just at the beginning of a lot of I think transformational events, no pun intended. So
no, that makes perfect sense. Also from my side, from a practitioner side, it seems that that previously people just wanted to let's move into a more live or low latency version of the world, and now they figured, okay, we could do that, but then there's also some things to consider. When you build a data product, does it really, if you cannot automate an action with it in real time, why do you need it in real time? You don't. So just coming back and forth, but I fully agree that it's probably one of the interesting things that also the confluence of the analytical versus the operational world, right? In the data space, where you have things like Snowflake which is going into the analytical, not real time. But now they also want to move into the more operational things side of things with Unistore. But I still think, I don't know what your prediction is, but we're still kind of a year or more away from that being, just something you'd consider building your actually live application with, right? where you do like an operational, really highly operational thing with low latency within the Snowflake space. But also alternatives, like not to be vendor specific. What's your view on that? Like,
yeah, I mean, I think there's a lot of cool stuff happening in the database space. I mean, single store is doing some cool stuff. Unistore, I think, is really promising. I'm sure Databricks is something coming out. You know, MotherDuck from Jordan Tigani is also really cool, using DuckDB in the, you know, I think locally, using Wasm. I think that's actually potentially the dark horse in this whole thing is small databases.
Small databases,
yeah, because think of it, you don't need to have the network latency of sending data back and forth with the wire. You can just do things on your machine. You know, the latest generation of Macs, especially, they're so powerful. That's what I'm pretty excited about. Those possibilities. And yeah, I think it's cool. I mean, people are starting to think of databases differently. I mean, Snowflake has, I think, a vested interest because of the data cloud, and they want to be the platform upon which all your data sits. And so any way you can get data in and make it useful to you know, to users is to their benefit for sure.
Right. So this is where you have the kind of new technology meeting also the network economies of with network effects, where you just would want to move to the cloud, not just because of the convenience that everyone else is there for integration purposes, rather than just because the tooling is so much better, right?
Yeah, integration. And what you know, I've been thinking a lot about the impact of data mesh, for example, and what I think the highlight to me is really the platforms that are going to come out to, and you know, I guess better share data sort of ubiquitously and allow people, you know, companies and organizations and departments to you know, to move data back and forth in a very seamless manner, you know, obviously with safeguards and governance and so forth. But if you think about it, the way we share data right now is actually kind of stupid. We use APIs, which are developed for like web applications specifically, and it's not meant for large data movement. I mean, pagination is like, why do we do this with? I mean, it makes sense for apps for sure, but it makes zero sense for data. So I think there's you know, it's not going to have to be a rethink of how we share data, but I think that's you know, things like data mesh excite me quite a bit. You know, the implications of that, plus these new types of databases. I wouldn't say new types of databases, but I think databases that can handle kind of more ubiquity.
Right.
So
you mentioned data mesh. Let me ask you something. What do you think about data mesh is something that most people get wrong?
I think it's a technology thing. I mean, it's more than that. I mean, Joe calls it a socio-technical phenomenon. I agree with that assessment or that observation of it. But what I see right now is I feel like there's a lot of vendors out there claiming to be data mesh companies, you know, and I think kind of tainting her message a lot, Jamox.
Right.
So it's a bit disingenuous, but vendors are going to do what they're going to do. I mean, marketing teams are going to find a way to, you know, slap up whatever, you know.
Well, they have plausible deniability. No, we're just helping you solve the data mesh with our technology, despite the fact that it has nothing to do with that technology.
Yeah, it's interesting, but you know, they're gonna do what they're gonna do. But I think that's the single biggest thing people get wrong. And plus, you know, the only thing I can say is like, you know, Jamont's written 2 articles and wrote a whole book on this, and those would be places I would start to understand it. You know,
right.
But I'm always a first principles person. I never try and like, you know, associate you know, my interpretation of things. I always try and just go back to the source and just read them, and then, you know, once you have that context, you can make up your own mind on it. But I don't know, what do you think people get wrong about it?
Well, I think we're kind of what we observe from my experience in Austria and Germany. There's maybe there's a slight difference to the U.S. market, but on our continental Europe, old school kind of world, there's an inflection point where everyone's running, especially the you know, successful established companies are running a very, very old data stack. And it's just been keeping it running like a classic motorcycle. You just would repair, polish, it'll get you from A to B. But suddenly there are things out there in the market which is like, why should you could drive a Tesla that could also power your house. So there's a whole lot of things you could do with your data team, with your data stack. And then suddenly someone comes up and says, well, let's just change things. Let's do data mesh, right? And then obviously the first question is, okay, which technology we're going to use, rather than how to set this up, how to set up our business in a way that is data product driven and can actually be best, I guess, supported by such an approach. And now the question that I wanted to ask is like it's almost like a chicken or an egg question for the average, let's say, big enterprise. Would you rather, if you were to kind of, without thinking of a concrete company, but just in general, would you say, okay, let's focus the resources first on underlying data infrastructure. Let's get the basics right and re-platform, kind of position ourselves in a way where you can set up these vertical product teams, data product teams, add and build AI, machine learning, what have you cases afterwards? Or would you say, no, that seems like too much of a bureaucratic process. Let's just build a clean, nice, POC MVP pipeline for an ML case, and then just add kind of around it and grow this to be the new infrastructure. That seems to be a question a lot of companies are asking themselves these days. What do you think?
I think it depends on the company you're at, right, and the culture and the willingness to either experiment or whether they just want to do things bureaucratically. I don't think there's it's a chicken and egg thing, sort of, but it's also kind of an A or B answer.
Right.
And so it really just depends, like, what's your appetite for risk and iteration and experimentation. If there's no appetite for it, then everything's done by committee, and there's no room for creativity, I guess. It's just it sounds very very European. So no offense, but
not taken.
Of course. But I would say it's. I mean, a lot of companies claim to be agile, for example, right? They claim to embrace experimentation. In reality, I think reality's far different than what people claim. But if you can get away with, I think, starting with a use case. I mean, I would start with the use case and then work from there. Start with something that's going to, 80-20 rule. It's 20% of stuff that's going to add 80% of the value, just the high impact stuff that's pretty low effort, and just start building off of that. I wouldn't do something like grand slam, like it's, dive in and build everything at once. Just figure out the use case and build it, because you're also developing the muscle memory, right? Of success. And if you don't have muscle memory, then it's, you're just going to kind of suck at what you're doing as a team and as a company. And the thing is, like, data teams, what I notice is they need to get wins. It's not like you just data is expensive. Teams are expensive, and so a lot of scrutiny's on there. If you're not, delivering something that stakeholders like,
they won't have the patience to stick around until we re-platform, right?
Probably not. No, and re-platform meaning like we're going to re-platform the team too.
Right.
So,
So no, it's that's pretty kind of on the other hand, the European approach is, okay, let's think this through and let's envision something that's likely to be stable for 3 to 5 years, and so it's more like this side of things where when we do things, we're serious and we stick to this long term. Kind of steer this ship away to another port and really go for it. So it's just a different. I guess it is almost like a cultural difference, right?
Well, in the book we advocate when you're choosing technologies or choosing architectures, like you should try and go over index on like two-way doors, right? So you can make reversible decisions, not a one-way door where you go in and you're kind of stuck, right? That's probably not the best idea, and so. Because the thing is, technology is changing very quickly too, and so if you can, architect in such a way where you're sort of gonna, you hopefully accomplish the goals you need to accomplish in the next 3 to 5 years, kind of what you're saying. But at the same time, if there's better practices that come out, you're not, monolithically stuck on this, this stack that you determined was the best thing 3 years ago. Because I mean, the stuff that we were doing 3 to 5 years ago, it's the world's changed drastically since then.
Absolutely,
in technology and practices. So and just given the exponential change, there's faster increase of change per unit of time. You can't just think linearly about these problems. You have to think very, exponentially and possibly multidimensionally as well. Not just thinking, it's from A to B, and that's where we go, and that's the stack we choose for the next 5 years.
Right, and ultimately, you mentioned just big data teams need wins, absolutely, and I think the wins should be more like for the business teams, for the business, and the data team is just the enabler of that, rather than just the win is, we just migrated X to Z, and who cares?
Well, I mean, the opposite would never be true, right? Like the business wouldn't be serving the data team.
Right.
Right.
So yeah, but that's that you still need to evangelize and explain and kind of also just help them get the most value. I think back to what we discussed earlier with Hadoop, right? I mean, you could do a lot of, let's say, automated things that are great, but you could never really onboard business users in a large scale. That's kind of this first generation big data and why BigQuery and Snowflake and all that. Like, you could just not have them on board. The barrier for them to be able to do stuff with it was just too high for a non, let's say, data engineer practitioner.
Yeah, and internally, like at a place like Facebook, right? That's why Presto and Hive were made, so they could bring business analysts closer to the large amounts of data they process, right? And so Facebook and Dremel and BigQuery were similar, at Google, and so because you have a lot of data, but yeah, handling that is not a pedestrian exercise. It requires a lot of skill, but at some point you need to make that translation layer, accessible to business users, and they help them figure it out on their own. It's pretty cool.
What do you think the biggest challenge is with still so much talk around data governance, and yeah, I also have the vendors saying we do data governance for you. You got these catalog companies, you got all sorts of ETL tools. Everyone is data governing your data. How should, let's say, mid to large organizations that are just swimming in legacy and silos and all that think about data governance? And is it again similar back to the previous question, part two? Is it kind of a challenge that should have like a huge, let's say, architecture and structure to it, and then run with the longer project, or how would you approach this? Assuming it's an organization that just sits on a lot of data governance issues.
It's a tricky one.
Quality and all sorts of...
And governance is one of these words, I think that it's, the connotations of it are, I wish we'd use a different word than data governance.
Right.
Yeah, these days it's just kind of a weird one. I mean, it's an interesting question. I feel like there's kind of data governance 2.0, so to speak, and that's kind of more of the modern approach where it's not as there's some sense of decentralization. It's not as committee driven, centralized as maybe it used to be. But back to your question about medium to large businesses, data governance initiatives. I think these are only successful if it doesn't feel like work to the people who have to, who are impacted by this. So if you're forcing data teams or stakeholders to do a lot of extra work, but without understanding what the benefit of it is, or them realizing value as a result of these efforts, that's where I've seen data governance things fail. It's like, and the other thing is where I was talking to somebody in Australia about this the other day, but it was this person did data governance at this company and felt like they had a lot of responsibility but no authority. So see what happens.
So they're saying we can surface the KPIs of how bad data is, but we can't really do much.
Yeah, it's a toothless job. It's like, okay, it's like handing out parking tickets or something.
Yeah, but on the other hand, if you just tell them, okay, you guys are the owners, then they're gonna be like, okay, but what's in it for us if we
That's
start
exactly it. Like, unless there's an incentive, it's as Charlie Munger always says, like, show me the incentive, I'll show you the outcome, and this is no different. That's where we've seen governance, kind of fall flat a lot. Is it just unless it's backed up by some sort of incentive, hopefully not not a stick, wouldn't be a carrot. That tends to work really well, but yeah, if you're first forcing extra work on people, nobody's going to want to do this stuff.
Right. And maybe if they really are serious about getting data products right, then a lot of these problems will kind of solve themselves away by the way of how new teams are organized, and it'd not be such a pain in the butt to deal with. Push, is this my KPI or yours? Who needs to solve this?
Right.
All right. Right, but then the question is, what do you recommend, established legacy enterprise data teams to step up their game? Should they get certified? Should they self-study? Should they take a gamble and stick with a large vendor? That's a very easy way out. How would they best position themselves to ride the wave of modern data engineering?
I mean, obviously read my book, but apart from that, you should. Again, I think it's understanding. Okay, so like, what are you trying to do as a team and as an organization at the end of the day? And work backwards from there, and then figure out what you can do to enable your team. I would say both from skills and from technology practices to accomplish those things. That's how I would think about it. Because obviously you're trying to at the end of the day you're employed by somebody to solve a problem. So so I'd work backwards from there and just figure out, okay, so how can I better use technology and better best practices and new ideas to accomplish those goals. Certifications are certainly a way if the certifications are relevant to what you're doing. If you're working in the clouds, I would highly suggest getting the AWS or GCP or Azure certification, depending on what cloud you're in. I think that's a good investment in understanding how these platforms want you to do stuff. All too often, what I see, companies and engineers think they know what they're doing in like AWS, for example, and then they just don't have an opinion about stuff. There's a certain way that these clouds want you to do things, and if you have an opinion about it, you're going to get schooled pretty hard. So, yeah, I mean, but it all depends too on whether or not you like to learn in the first place.
Right.
So,
well, I was thinking more along the lines also of you could and should, I think, establish. I mean, if you're an organization of that size that can support this, obviously, but you should establish some sort of a data academy of some sorts where you just have people willing to share and train others. So then, users would just love to there's a lot of early adopters and later adopters. Everyone would find something useful, but they would know that they could get basically the most use of it.
mm-hmm.
And I think it's something non-obvious, right? They would work with a company like ours or whoever they prefer to actually get more people to do more projects, but they'd never stop and think and say, but listen, how do we make sure that our people are consistently learning about these newer things?
Well, absolutely. We see this all the time. In fact, my company, Ternary Data, we're actually pivoting out of consulting into just education. We got so much demand because of the book for just trainings and workshops. And we felt that it's needed. I mean, if you look at a lot of data teams, the skills aren't standardized, competencies aren't standardized, knowledge isn't standardized. And so what happens is the people have very random standardization, or lack thereof, I would say. There's standard skills, random skill sets. You would never build a sports team that way.
No.
Right? The way we, sports teams train, they drill, and they have playbooks and stuff, and data teams are nothing like that. It's like, oh, you can write SQL, cool. Like, you're on the team, oh, okay, you have experience with Snowflake, right? And I think it's a really backwards way of looking at things. The amount that I would say the lack of investment in training and upskilling for data practitioners is shocking. And then people wonder why they're spending a bunch of money on data professionals and possibly not getting the full value out of those people, right? You're not investing where you need to, and it's a small investment. Buying a book for somebody, having book clubs,
right?
It goes a long ways, right?
But also some of the basics. No, I mean, obviously, writing SQL is the first thing. Yeah, maybe you could do some Python. It's also fine for friendlies. But then, I think understanding data modeling, data architecture is to data engineers what understanding algorithms is for software engineers, right?
Yeah.
There's some of this non-obvious thing that you wouldn't just, I need to solve a problem. I'm going to quickly look it up in Stack Overflow. You have to spend time. And if you do it in a structured way within an enterprise and get a company to help you out, then that's like you said, it's a good return on investment.
Yeah.
For them. And sports teams. I believe you do martial arts.
Yeah.
You do martial arts. What do you do, if I may ask? Yeah. So you just mentioned building data teams the way you would build sports teams, and I understand you do martial arts. What are your learnings there that are transferable to building a data team? And which martial arts do you do, by the way?
I've done quite a few over the years. Right now I sometimes go do jiu-jitsu, probably less than I should, so I want to do more of that. But I've done like Muay Thai, boxing, jiu-jitsu, obviously more traditional martial arts as a kid, but I don't really count those. It's like Karate Kid stuff, so... But jiu-jitsu is fun. I like that a lot. I mean, it's fun because I think you can still do it as you get older. Not get hurt as much. So, yeah, I don't know. It's fun. But how does it apply to data? It's not in the obvious sense. You're not gonna go like beat up your team members or something. But I think there's a bit of discipline to this. That I think transfers over. I was talking to Kent Gagiano about this as well. He's a 8th Dan Taekwondo master and teacher still. So he drew a lot of parallels between martial arts.
Well, I remember there was recently a month ago or so a podcast where you guys spoke about this. Yeah,
that was cool. So
yeah,
I just think it's I don't know. There's definitely things you can take away from that. From martial arts that apply to data. But I'd say it's maybe just a discipline of just continuously getting better at stuff, or
right.
But that's about it. You said you also.
Yeah, I do IDF Taekwondo.
Oh, nice.
Still doing it for many years, and
fun.
Never really done grappling with Jiu-Jitsu, but I guess that's the modern stack.
It's but I kind of view the parallels like MMA, for example. I think, or it does apply to it applies to any field really, where you have to take what works in a lot of fields, and combine them into something that's a bit more holistic. That's what I feel like MMA is. And then I think MMA did a really good job at like kind of keeping what worked and removing a lot of stuff that didn't, like fancy kung fu mastery stuff. Like obviously, like did not work out very well for people.
Yeah, it's just bad for your knees. That's the equivalent of running Hadoop in 2022.
Yeah, but it's there's a lot of parallels, but I won't get to it. It's some kind of hokey. So.
All right. Well, last question before we wrap this up. What other books do you read other than apparently everything's data space?
I mean, I've read a lot of the books in data space at this point. I hope there's more to come. But I'm reading. I read like probably 1 or 2 books a week, so quite a few. I've been reading the autobiography of Paul Volcker, the Fed chairman who crushed the back of inflation. That's a good book so far. So, I read a ton. So.
Everyone should, by the way, everyone coming from banking, I think everyone should read that book, since there's just. I believe very, very few people having the discipline to Paul Volcker side of this, Yeah,
it's gonna suck, but but it is what it is. But yeah, favorite book of all time is probably Poor Charlie's Almanac, the collection of Charlie Munger's talks and some writings. So that's like my Desert Island book. It's also like weighs 1,000 pounds and is very expensive, but for a book. But I think that's a good investment if you're gonna get. A book. Well, actually, I don't think that's true. Actually, most people probably hate it. I have like weird taste in books, but But the musings of like a 90-plus-year-old man, right? It's kind of like, wow, what does he have to say? But he's like by far the smartest person I've ever met. So that's interesting.
Yeah, and all of you Bitcoin fans, read some Charlie Munger.
Oh yeah, I got some things to say about that.
All right. Well, Joe, it's been great talking to you today.
Likewise.
And, thanks everyone for watching this, and see you soon.
All right, thanks. Bye.
Bye.